Welcome to aminacademy.com. In strength of material, let us discuss about thermal stresses. A thermal stress is a mechanical stress created by any change in temperature of a material. Suppose in structural, steel or whatever the metals used, regarding the temperatures, it tries to expand. The metals are try to expand. So these stresses can lead to fracturing or plastic deformation depending on the other variables of heating, which includes material types and constraints. Here, the thermal deformation due to thermal conditions is varying from metal to metal. Temperature gradients, thermal expansion or contraction, and thermal shocks are things that can lead to thermal stresses. This type of stress is highly dependent on the thermal expansion coefficient, which varies from material to material. In general, the greater the temperature change, the higher the level of stress that can occur. Thermal shocks can result from a rapid change in temperature, resulting in cracking or shattering or failure of structure. Here, look at this figure. Thermal stresses are the stresses induced in a body due to change in temperature. Thermal stresses are set up in the body when the temperature of the body is raised or lowered and the body is not allowed to expand or contract freely. Suppose, look at this first figure. Here, due to thermal temperature increase, this length will increase if there is no outside load is applied. That means if it is freely expand, there is no thermal stresses is created in the body. Now, but if the body is allowed to expand or contract freely, no stress will no stress will be created if there is no external forces applied. But suppose if external force is applied to stop the expansion due to increase in temperature, there will be thermal stresses created inside the body. Now, consider the body which is heated to certain temperature. Now, let us write the given things first. Let L equal original length of body. Original length of the body. T equal rise in temperature. Rise in temperature of the body. E equal Young's modulus. Alpha equal coefficient of linear expansion. Linear expansion. Then delta L, that is dl, is extension of rod. Extension of rod due to rise in temperature. Due to rise in temperature. If the rod is free to expand, then extension of the rod is given by. Suppose the rod is free to expand due to increase in temperature. Therefore, you can write dl equal alpha into T into L. That means coefficient of thermal expansion multiplied by temperature changes and the original length of the rod. Now, here the original length is L, that is AB. Here after heating the body, the point B goes to B dash. That means the length will increase, and due to that external force is applied, that means there is no expansion afterwards. Due to that stopping that expansion, thermal stress is created in this body, that we'll discuss now. The compressive strain is decrease in length by original length, which is equal alpha TL over L, original length, so which is equal alpha T. Now, but we know that Young's modulus equal stress over strain. Therefore, stress equal strain into E. Therefore stress equal alpha TE. Stress equal strain alpha TE. And rod or load or thrust, load or thrust is given to prevent the expansion. Thrust equal stress into area of cross section of the rod. We can write this one is alpha TE A. Now, if the ends of the body are fixed to rigid support so that its expansion is prevented, then compressive stress or strain will be set up in the body. These stresses and strain are known as thermal stresses. Therefore, thermal stresses and thermal strain. Let us do thermal stress equal thermal strain. First we'll do thermal strain is, we'll write for small e the symbol, extension prevented over original length. Extension prevented is alpha TL over L, that is delta L by L, which is equal alpha T. Thermals, again you can say thermal strain thermal 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 stress equal, right, sigma equal thermal stress equal to thermal strain into E. Thermal strain into E. Thermal strain is alpha T into E. This stress is also known as temperature stress and strain is known as temperature strain. Now, Note the point here. Stress and strain when the support is yield. Stress and strain when the support what is yield. If the support yield by an amount equal delta, if the support yields an amount delta, then then actual expansion is given by expansion due to rise in temperature minus delta, that is alpha T L minus delta. Therefore, we can say actual strain equal actual expansion over original actual expansion over original length equal alpha TL minus delta over L. Actual and actual stress is equal actual strain into Young's modulus. Actual strain we have alpha TL minus delta over L into E. We have done. Please subscribe our YouTube channel.